All right. Just before we get started, just because this will come up, the rounding rules. So when we're dealing with rounding with you guys, the first thing is you need to know, hold on one second. So like these initial, like 75 milligrams to grams, 125 micrograms to milligrams, you don't round these, okay? The only time you round is like when you're going from pounds to kilograms, you would round to the nearest tenth for that. But when you're doing inter-unit conversions, meaning metric to metric, do not round those numbers, okay? So this, I believe, ends up being 0.075. That's the answer. Do not round that to 0.1, okay? The only time that the rounding rules that I'm going to go over here in just a moment apply are really from like 6 down, okay? And then anytime you do between 2 different units, so like when we go from pounds, standard units to metric kilograms, if rounding applies, then you would round those, but basic unit conversions do not round. Now, the other rounding rules, when it comes to drops, that's what this GTT stands for, and you'll see that in a minute when we get to it. Always round to the nearest whole number drops, because you can't give somebody a decimal of a drop. All right. You can give them a partial drop, you can't give them a partial drop. You either give them a drop or you don't give them a drop. That's how that's indicated. So if you got 49.9, 49.8, 49.7, 49.6, 49.5, the answer is 50 drops, okay? When you have a number greater than 1, round that number to the 10th. The example here is, let's say you get 1.75, round that to 1.8. And if you have a number that's less than 1, you can round that to the 100th place. Example here is 0.175, where the 7 is in the 100th place. So I round that up to 0.18. Okay, so you'll see that throughout. So a number, you want to have an answer that has 2 significant figures in it. So just make sure when you're doing these, if you ever get tripped up on why they did round or why they didn't round, now hopefully you know the secret there. So, all right, let me get a blank piece of paper here, and then we'll get started. We'll start with number 4, I think was the first one I saw. 4, 6, 7, 10. So if I skip something, I'm sure someone will let me know. All right, so number 4 is an example of going from different systems. So number 4 says we have 2 teaspoons, and I want to go to milliliters. So I want to know how many milliliters that is. And so you need to know your conversions. And so this one, you don't have to do too much math necessarily. If you know that 1 teaspoon is 5 milliliters, 2 teaspoon, 10 milliliters. Okay. If it were tablespoons, it would be 15 milliliters, and so on and so forth. If you confuse that little t with a big T, then that may have been why you missed this particular problem, if that was missed. But that's how you would answer that question. If you're going to do dimensional analysis for this, this is what it would look like. 1 teaspoon is 5 mil. This is supposed to be a lowercase t. And that's where the 10 mil comes from. So 1 teaspoon is equivalent to 5 milliliters. We cross out the teaspoons, and then that would be question 4. Okay. Then question 6. So that was 4. Question 6 is the fluid replacement. So I have a question, or I have a strategy for you answering this. What you're going to do is, so it tells you for every 125 milliliters of urine output, you're replacing with 40 milliliters of water. And then 500 milliliters was what was actually voided by the patient. So what would the replacement volume be? So the way I do this question that might be helpful for you is I set it up with the, I call it the expected output, oops, that is not what I want to write. The actual out over the expected out times the replacement. Okay, so this is all based off of the volumes. So actual output over the expected output times the replacement volume. So for this particular example, the actual output was 500 milliliters. The expected output is 125 milliliters. And then a replacement volume would be 40 milliliters. And then you would just do 500 times 40 divided by 125, and you would get 160 ml. Now, how might this question look on your test? Well, actual output could be different. The expected output could be different, and the replacement volume could be different. Okay, so let's use as an example, let's say we have the same replacement volume, but this time it was 200 milliliters is what was actually what was the actual what the patient actually voided. So if it was 200 milliliters, I'm going to set it up the same way. The only thing I changed was the actual output. Okay. And then you would just do the same thing, 200 times 40 divided by 125. And I closed out of my calculator. So give me 1 second. Nope, that's not what I wanted. So 200 times 40 divided by 125. And you would get a replacement volume of 64 milliliters. This one was, didn't answer it, 160 milliliters. The other thing I'll add about this this particular question is pay attention. Like, so if your actual output is greater than the expected output, you know that it's the replacement volume is going to be greater than 40. If the actual is less than the expected, then that number will be less than 40. So like if this was, let's say 100 milliliters, you would expect your answer to be less than 40. If it's 200, you expect it to be more than 40. So if you happen to, confuse what goes where, that'll help you out when you're getting your final answer. Just make sure it doesn't make sense. Okay. All right. Number 7, I think was on there. So with 7 says you're to administer 250 milligrams Dilantin. How many teaspoons will you give if it's labeled as shown below? So keep in mind, make sure you read the directions. What are they asking for? They're asking for teaspoons. If it asks for milliliters, then you would give it milliliters. Don't get tripped up on this question because on the test, it might switch it to milliliters. Okay, so just make sure you read what it says to do. So the order. So I'm going to show you this 2 ways. I'm going to show you that what some people call my way, which is just dimensional analysis. And then I'll show you the ordered over half way. Okay, so the order is 250 milligrams. I don't want milligrams. I eventually want teaspoons, but before I can get to teaspoons, I just need to get down to a different volume. So the label says 125 milligrams per 5 ml. Now, just to be consistent with the dimensional analysis model, since I know we're looking for teaspoons, I'm just going to go ahead and make the conversion of milliliters to teaspoons, where we know that 1 teaspoon is 5 ml. Okay. And then when I do this calculation, I get 2 teaspoons. Okay. Alternatively, if you're doing ordered over half times your quantity. Now here's where you can alternate. So if you already know that 5 milliliters is 1 teaspoon, then you can just go ahead and put that as your quantity, or just leave it as 5 milliliters and then convert it to teaspoons. But either way that you do this, you get the same answer, 2 teaspoons. All right, then we got 10 and then 16 through 25. Let me just see. I see there's some additional questions here. Yes, you need to show your work. Good. Okay, so let's go on to number 10. All right, so number 10. And then I'll do number 11 as well, since someone asked about the 2Bex. So I want to make sure I address that. So number 10 says the order is amoxicillin 0.375 grams every 6 hours. You have available amoxicillin suspension 125 milligrams per 5 ml. How many milliliters we give per dose, and then don't forget to mark the cup. So little trick here for you guys. Keep in mind that if they ask you to mark the cup, that means your answer is on the cup. Okay, so they're not going to tell you to mark it and it's not going to be on the cup. Just a little piece of information. Now, some of these cups, sometimes they're ml and cc, sometimes they're ml and then tablespoon, teaspoon. So just keep in mind like what they're asking you for. Every time I've seen this question, though, it's always been asked how many milliliters and then the mark it on the cup. And I don't know if mark it means circle it or put a line to it, but just make sure you indicate that you know exactly what it is. So there's a piece of information you need to know here that will help you to solve this. First of all, if you recall from way back when you first learned about the metric system, which may have been years, decades, or maybe you just never learned it or don't remember learning it, you need to know that you cannot do math with these until they're within the same unit. Okay, when you can, if you can think in powers of 10 and just do that all in your head, that's certainly a possibility. But for the most part, you need to convert either grams to milligrams or convert milligrams to grams. So they're both in the same unit. They need to both be on the same page in order for us to do any kind of math with them. So let's get on the same page. So 10, okay. We have 0.375 grams, and I want to go ahead and convert that to milligrams. Now, the reason I want to do that is because that's just what I've chosen to do. You can convert milligrams to grams, and that's perfectly fine. You'll end up with the same answer, but it's completely up to you. So if I'm going to do this dimensional analysis, okay, we know the conversion between grams to milligrams is that there are 1,000 milligrams in a gram. Okay. Sorry, my camera will change here and stay in focus, hopefully. All right. The other thing you could do alternatively, and this is what I personally do, is I just move my decimal over 3 places. But I also know that that's the difference between grams and milligrams. So if you're not quite there yet, you have a calculator, you can multiply by 1,000. As long as we both get 375 now milligrams, we're all on the same page. Now you can do math. 375 milligrams times, and what are we converting? Well, the available is, we want to convert from milligrams to milliliters. 125 milligrams, 5 milliliters. You do 5 times 375 divided by 125, and you will get 15 milliliters. And then on your cup, you would just indicate 15 milliliters. So sometimes it just depends on your instructor. You might want to just draw a line right across, so you know at the 15 milliliter mark. They may want you to fill this in. I'm not entirely sure how they want you to do this on a piece of paper, but just make sure you mark the cup. Okay. Same thing would go from like when you do your 2Bex, you're going to just mark on the 2Bex. So like I said, we'll do number 11 and I'll just show you how to mark it on the 2Bex. So again, the lesson here is make sure you have similar units. You'll see that moving forward with classes, you'll have other classes where or other questions later on where it'll be grams and you need it in milligrams, or it'll be in milligrams and you need it in micrograms. Just make that conversion and you'll be good. And if you're doing ordered over half, this would be 375 over 125 times 5, and we'll come up with the same answer. Okay. I said I would do 11 before we move on to 16. So 11, I'm going to assume that everyone knows how to answer the question. It was just marking the 2x, but I need to know what that answer is. So my order is 75. I have available 50 milligrams per milliliter. 75 divided by 50 is 1.5 milliliters. So how I would mark the 2x, because it's 1.5, right? So we would just mark the 1.5. Okay. So I don't know if you're supposed to put an arrow or circle it. Just make sure you circle the correct one. Okay. And then notice that these are all, because I believe this is, let's see, 0.1, 0.2, 0.3, 0.4, 0.5. So these are all increments of 0.1. So just if you were to get an answer of 2.1, 2.2, 2.3, 2.4, 2.5, you can see where you would mark on the syringe based off of those things. All right. So questions now 16 through 25 is what we're going into next. Okay, so I think now we're getting into our flow rate questions or drop rate questions. So for 16.
I had a question about that, if you don't mind. As far as number 16, you see where it says GTT per minute on the paper. So that would be the drops per minute.
Mm-hmm.
With that being the case, what you have in the top of the problem, would you use that to determine what you're going to put for the answer? So how it says 75 milliliters in 25 minutes, and then it has drops per minute. So it will be in minutes.
Yes, yeah, and that's the standard for drop rates. Is it's at least I've always seen it as drops per minute.
Okay, and when we get to number 18, I have a question about that one as well.
Okay, yeah, you got it. Yeah, by all means, if like while I'm working through a question, if you have a question, just unmute yourself and just ask away. I obviously can't. I'd like to say I'm great at multitasking, but I'm a guy. I do one task and then I do the next task. So right now my mind's 16 through 25, showing you guys how to do it. So stop me just like you just did. So thank you. All right, so 16. So flow rate. So in order to solve flow rate problems, you need to know two pieces of information. You need to know the flow rate, and you need to know the drop factor. Once you know those two pieces of information, then you can calculate your drop rate. Flow rate is typically in milliliters per hour, but it could be in milliliters per minute. Drop factor is always going to be in drops per milliliter. Sometimes it'll be written out as drops, DROPS, but the abbreviation for drops is GTT. If you're wondering why it's not DR, that's because that's the abbreviation for drams, which is an apothecary unit that I guess they didn't want to confuse people with. And then if you're ever wondering who in the world uses drams, if you have perfume at the house, it's measured in drams, so you can look at that. And then the drop rate is always going to be in drops per minute. Okay, I've not seen drops per hour, anything like that. It's always going to, it seems to be in drops per minute always. Okay, so number 16 says you are to administer the 5% dextrose water IV solution at a rate of 75 milliliters in 25 minutes. What is the flow rate in drops per minute? And then we got to look at the drop factor. And then on the label, it tells you 15 drops. If for some reason, like if you're on ATI and it doesn't give you the drop factor, they're typically talking about what's called micro tubing. And micro tubing is typically 60 drops per ml. Okay, so it's commonly known, maybe not to you, but apparently for micro tubing. But every tubing, there's a whole variety. These come in 15, 10, 5, 20, 25. There's a variety of different drops per milliliter depending on the size of the tubing. Okay, so it says 75 milliliters, 25 minutes times 15 drops per milliliter. And then you just multiply across the top, divide by the bottom, and then you'll get 45 drops per minute. Now, I will say for this question, if you're trying to do ordered over half, it's not going to work because flow rates don't follow the order over half style that the rest of these things do. Actually, flow rates in general don't follow that ordered over half style because the flow rate is just volume over time. And so that's what you have to do is just organize your formula into volume over time. So if you are just staunchly against dimensional analysis, it is helpful to do that. But as long as you know how to just multiply flow rate times drop factor, you're going to be fine. Let's look at 17. So 17 is not a drop rate question. 17 is another flow rate question where we're calculating milliliters per hour, but they give it to us in milliliters per minute. So what are we going to do? We're going to convert minutes to hours. So 120 milliliters, 90 minutes. Now the slow dimensional analysis way is you would just convert minutes to hours. Hopefully you know that minutes, there's 60 minutes in 1 hour. Okay. And then when you do that calculation, I believe you get 80 mil per hour. Let me just double check. So 120.
Yeah, it's 80.
Okay, thank you. Times 60 divided by 90, and you get 80 mil per hour. Alternatively, you know that 90 minutes is what? 1.5 hours, right? So you could have also done this. Divide that by 1.5, and you'll get the same answer. So if instinctively you did that, you did it right. Okay. This question and like the question 19, the Ringer's lactate question, is really just volume over time. And then what does that equal? Okay. So you just have to do some very straightforward division, but sometimes it feels like there's more that you need to do, but there's not. This is all you need to do.
So with most of these questions, could you really just look at the ending of the question? So like for the one we're on now, where it says 120 milliliters in 90 minutes, and then it wants you to calculate the flow rate in milliliters per hour. Could you just look at the milliliters per hour and know that you have to convert the 90 minutes into an hour? And then for that Ringer's lactate question, 375 milliliters of Ringer's lactate over 3 hours, you know that it's going to be in hours. You really don't have to convert anything. You just know that the answer is going to be in hours.
You got it. Yeah, that's it. I mean, the only way you know what to do is by what is the question asking you, right? And then sometimes, like on ATI, I've seen the questions where they'll say, calculate the flow rate, and they don't tell you what to use. So flow rate is typically, and I would say almost exclusively, at least within nursing, milliliters per hour. And then drop rate is drops per minute. So as long as you know that those are the standards, then if for some reason it doesn't ask you, but on your tests, because I'm the one who wrote your tests, they will have, what units you're looking for. So as long as you can navigate your way to solving it that way, you're doing exactly what I would do.
Okay, I have a question.
Yeah.
I don't know if I'm thinking like way too much into this, but what I'm confused on is just like the formula, because it's saying like, what is the flow rate? But then I don't even know how to explain what I'm saying. Like, it says, what is the flow rate in drops per minute? But then on the formula, it's saying that that could be, I can't see your page again. Hold on. It could be the drop rate is the drops per minute, but we're looking for the flow rate. Like, am I confusing myself more than what it needs to be? I don't understand.
Okay, good. Yes, so you are. These questions are commonly missed just because you're looking for more to do. And I think that's, you're like, well, okay, where's the drop factor? You only need the drop factor is if it's asking you for the drop rate. It didn't ask you for the drop rate. It asked you for the flow rate in milliliters per hour. So you're looking for information that's not there, this is very common because I think you guys being nursing students, you're looking for, you're looking for more. And with the math stuff, sometimes it is just that milliliters per hour and then reduce, meaning 375 over 375 divided by 3, 125 milliliters per hour, you're done. There's no additional thing to add, multiply, divide. And then you'll know you're doing a drop factor problem because it'll ask you for the drop rate and it'll give you a drop factor. And that's another way to differentiate. So for 17, it just says calculate the flow rate, and all a flow rate is volume and time. And then the time, they wanted it in hours. So you just provide it to them in hours.
Okay, thank you.
You're welcome. Nope, yeah, don't get too much into your own head trying to like look for extra things, because and you're not the only one that I've heard that. I've been doing this for years. Actually, I've been working with nursing students over 10 years, and it's a consistent thing. So nothing's changed. If anything, it's stayed about the same, and everyone asks that similar type of question. So don't feel like, oh, it's just me. There's more than you think. It's just some people aren't willing to say it. So thank you for saying. Okay, let's move on to, I need a new paper. So that was, we just did 17. Okay, so 18 is the next question. So 18 says, you have an order of 0.9% sodium chloride, 500 milliliters IV. It's infusing at 125 milliliters per hour. We just want to know how long it's going to take to run. Okay, so you have 500, 125 milliliters is disappearing into the patient every hour. We just want to know, when do we need to change the IV back? The way I would set this problem up is 18. The way I would set this problem up is I would start with my 500 milliliters, which is my total, how much I have in the IV. And then I would convert milliliters to hours. I know that it's infusing, or that the flow rate is 125 milliliters per hour. I'll double check that I set it up right by eliminating milliliters, and I'm left with hours, and then I get 4 hours. The way that this could get challenging is, let's say it said 500 milliliters infusing at, 300 milliliters per 20 minutes. Then you just want to convert out minutes to hours at the end. And I think you guys know how to do that at this point. It's just a matter of, if you're going from minutes to hours, you divide by 60. If you're going from hours to minutes, you multiply by 60. 19 is just the Ringer's lactate question, 375 milliliters, 3 hours. And this is where, like I said, this is a commonly missed problem because students are looking for more to do. There's nothing more to do. Just 375 divided by 3, and you get 125 milliliters per hour. You're done. So if they tell you to show your work, you're really just writing it out. Okay, for that one. All right, 20. 20 is another drop factor question. And we know it's a drop factor question because of 2 things. There's a big picture of a tube, and then it tells you what is, and asks you what will the flow rate be in drops per minute. So the order is 1440 cc's. You know that cc's and milliliters are equivalents, and it's infusing over 12 hours. So 1440 cc's, 12 hours times the drop factor. Okay. Now, the other thing is with the drop factor, it tells you it wants it in drops per minute. So if you're following if you're a purist with dimensional analysis, you would then just convert this. You would convert your hours to minutes. Okay. And then you'd get 20 drops per minute. Now there's a couple of shortcuts for this. So one thing you can do, and I'm just going to write some shortcuts in red. One thing you can do is you can take that 1440 cc's per 12 hours, reduce that to, I think it's 120 cc's per hour. Okay, so 1440 divided by 12 is 120 cc's per hour. And then you can further reduce that to being 120 cc's over 60 minutes. And then you can times it by 10, and then you get the same answer, 20 drops. Or you could do, if you know that 12 times 60 equals 720, now you know you can just plug in the 720 here. If you're already in minutes, you don't have to do this step, and then you'll come out to the same answer. So these are just alternative ways to kind of set up the problem. $21. Okay.
Am I the only one who needed 21 through 25?
I don't think so. I saw some others mention beyond the 20s. So and I don't have a problem with working through it. So yeah, I had someone else ask about 22. So yeah.
Okay, I don't need 21.
Okay.
If no one else wanted 21, I don't need it.
Okay, that's fine. Yeah, we can skip 21. I'll just talk about 21. The trick here is just choosing the strongest concentration. Strongest concentration, 20 is greater than 10, 10 is greater than 5. So 20 is the bigger number. 60 divided by 20 gives you 3 milliliters. Okay, so there's and then using knowledge from 21 is how you would also solve this problem. The difference is on your label, you have some extra information that you don't need to solve the problem. This milliliters diluent added, that just tells the pharmacy how much water to add to get to these concentrations. So you could ignore this column, the milliliters diluent added, and then just focus on the units per milliliter solution. And then which one's the greatest concentration? The 1 million units per milliliter. So solving that question, this is 22. We have 750,000 units of Pfizer pen. I don't want units, I want milliliters. 1 million units. And then per milliliter.
Can I ask a question?
Yeah.
So when you're doing these choice of strength reconstituting, you always pick the largest number.
You pick
So you pick the 20 milligrams per milliliter in number 21, and then you pick the million in 22. So that's always the largest number is always the greatest concentration. And then you just divide that by the milligrams that you're giving or the units you're given.
You got it. Yeah. So,
So that's it. So that dilute added was just to throw you off.
Right. Well, that's what would be on the label.
Okay.
And so that's why they're asking you that, just to kind of see if you can sort through the information. But the mill or the I chose the strongest concentration because the question said to choose the strongest concentration. If it told you to choose the lowest concentration or the middle concentration, then that's how you would go about
Okay, I see.
choosing the other ones. Yeah, because you could still get the appropriate dosage using a different concentration, but there was a couple of years ago when this this test initially went out, there were a few, like some people chose 250, some people chose 500, some people chose 1 million. They were all technically correct, but the key, whoever was grading it only gave them credit for answering it one way. And so when I went back in, I added in the strongest concentration. That way everyone chose the strongest one. I will say something to pay attention. You could have some variations of the concentration where it might say like 5 milligrams per 2 ml, 10 milligrams per 3 ml, and 20 milligrams per 4 ml. You want to reduce that to find out which one is actually the higher number. So that's, but I'm going to be honest with you, I haven't seen that as being conflicting or a question that's been asked for nursing students, but that is a hypothetical situation where you'd want to make sure you pay attention to that you're looking at. They're all getting them reduced down to.
So would you just do the desire over half times the quant or the whatever the ml?
Yep.
And then you would just pick the smallest number out of that because it'd be the least amount for the highest concentration.
That sounds right. Yeah.
If it was the highest concentration. Okay.
Yeah.
All right.
That's essentially what you're trying to do is you're trying to give the smallest amount with the biggest concentration, essentially.
Okay.
So yeah. And then you should get 0.75 mil. And then you would leave it at that. You don't round that at all. That's the answer, 0.75, because it's a number less than 1.
Thank you.
You're welcome. All right. So for 23 is just doing, you can do order over half. Just do it twice and you'll add up the milliliters that you get, and that's your answer. And I'll go through that in just a second. And then 24 and 25 is just giving you some extra work. So 25 is very similar to that, the question about the amoxicillin, where you have to convert micrograms to milligrams or milligrams to micrograms first, and then you can solve that problem. And then 24 is just accounting for the patient's weight. So I'm just saying all that right now because I need to go get some more paper. So I will be right back and I'll get some more paper so I can work through 23, 24, and 25. So I'll be right back. Okay, so 23 is the mepridine or meperidine visceral question, where it gives you an order of both, and then they're injectables, and we want to add them together in order to get a total for the injection. So it's very similar to like mixing its insulin, where you're just kind of calculating the total that's going to go into the syringe. So for 23, start with the visceral. The visceral is ordered 60 milligrams, and I'm going to do the ordered over half this time around. 50 milligrams is what we have available per ml. And then 60 divided by 50, we get 1.2 ml. And then the mepridine, however you pronounce that, order is 85 milligrams. Available is 75 milligrams per milliliter. And then this one, I think you get a decimal answer. So 85 divided by 75 gives me 1.1333 repeating. And so what you're going to do is you're just going to round that number to the nearest 10th because it's a number greater than 1. So 1.1 ml. And then you're just going to add these two together. So we're going to add, and I'm going to get 2.3 ml. So you've already done this before. You've done this before. We're just now combining two things to give you an extra step, which is just adding them together. 24 is a weight-based question. You'll see a lot more of these when you get into third semester, when you do the heparin protocol, and also when you do pediatric dosages. Weight-based calculations become very important. So it tells us that we have Dilating 15 milligrams per kilogram loading dose. Then give them 300 milligrams per day. And then now we're going to calculate, because it says specifically for the loading dose, how many milligrams would you administer for a patient who weighs 176 pounds? So 176 pounds, we need to convert that to kilograms. We do that by dividing by 2.2, and I get 80 kilograms. Then I'm going to multiply by the loading dose, which is the 15 milligrams per kilogram. And then 80 times 15 gives me 1200 milligrams. Now, alternatively, the question could have asked how many grams to administer. Then you would just convert milligrams to grams. But as far as I know, that'll probably stay as milligrams. If for some reason you got like a question where the weight was where you had a long decimal here for the kilograms, convert this to the, or round this to the nearest 10th, then multiply by the loading dose. You should be fine either way and get to the same answer, because you would still round to the nearest 10th here. But I would just say as a good rule to follow is once you convert pounds to kilograms, whatever that number is in kilograms, round to the nearest 10th in case it's not a whole number. And lastly, 25. Says that you have, that the physician has ordered 500 milligrams of entecavir, and the oral solution contains 0.05 milligrams per milliliter. How many milliliters will you administer? The trick here, again, very similar to that amoxicillin question, is you need to convert micrograms to milligrams or milligrams to micrograms. Now, my strategy is I always take what I have been ordered and I'll convert that to milligrams. That way I don't have to worry about changing what I have available. So let's convert micrograms to milligrams. There's 1,000 micrograms in a milligram, and I get 0.5 milligrams. Now I can use that as my order. And then if I'm doing ordered over half, 0.5 over the 0.05 times my milliliter, and then I get 10 milliliters.
Thank you.
Yeah, you're welcome. Thank you for asking the questions. Are there any other questions from your practice test or any other questions in general about the test?
So is the actual test, it's going to be pretty much just set up just like this practice test?
Correct. As a hypothetical flow rate question, let's say I have something that's infusing at 120 milliliters. Let's just say in 2 hours. Okay. With a drop factor of 15. And I want to know what is the drops per minute. So go ahead and start with that. I'll let you try it first, and then let me know what you get, and then we'll work, and then we'll confirm the answer. All right, so let's solve this real quick. If you're still working on it. So the correct answer is 15 drops per minute. So let me show you what we're going to do. So remember, flow rates or drop rates are always going to be flow rate times drop factor. Now, I unintentionally made this question kind of cancel out. But anyways, so we have 120 milliliters in 2 hours. I want to reduce that, or I want to convert hours to minutes. So I'm just going to go ahead and do this real quick. I'm going to convert hours to minutes first, just to show you an alternative way of doing this. What I'm going to get is 120 ml and then 120 minutes. Okay. So they, obviously the 120s cancel out. Times 15. And that's drops per milliliter. And that's why we get an answer of 15 drops per minute.
And we always want it to be in minutes, right?
Correct. And that's what I asked for, right?
Yeah.
Okay. And that will always be asked for you. I can only think of, like, on the ATI, it might not say that. I do think the ATI does say it though. But if on the ATI you get some of these practice questions like this, or test questions, however they do ATI with you guys, it should say to calculate the drop rate in drops per minute.
Okay, thank you.
You're welcome.